Hi everyone, today we're going to be looking at Dijkstra's pathfinding algorithm. But before I start, can I please request that you like and subscribe our channel? So, Dijkstra's pathfinding algorithm, this is normally a topic that students tend to struggle with a little bit, but I'm going to try and make it as easy as I possibly can. The first thing that we need to understand is why Dijkstra's is used. Now, this is a pathfinding algorithm that is used to find the shortest path between one point and the destination. So often used in data transmission, where you might be transmitting a file or data from one computer or device to another along a network using the most convenient, shortest path. But it can be used in other areas such as traveling, Google Maps, for example, finding the shortest route from a start point to the destination. There's other uses, including games, so maze games, where you're trying to work out the path to get from A to B in the shortest amount of time or distance and so on. So just having a look at this, how we could record, we have a data structure here with some data. So we're just going to have a quick look at this and consider what data structure that is, because it's commonly asked in the exam before they get you to work out the shortest path. This data structure, as you will all be aware, is known as a graph. If it's 2 marks, then they are likely expecting you to say something along the lines of a weighted undirected graph. That will guarantee you your 2 marks. A weighted undirected graph, because you've got values or costs or distance, whatever that might be representing. So it has a cost along the edges, which makes it weighted. You've got no arrows, so that means that there is no direction. So it's an undirected weighted graph. Okay, so that's the first little exam tip there. Now, we've got this graph that is always going to be given to you. You may or may not have a table to represent and work out the calculations. If you are not given a table, then my recommendation is that you draw it out. So you ideally want to memorize this. The node, as in the list of nodes. So we're going to list those. A, B, C, D, E. Alphabetical order just makes it a little bit easier. Right, we've got the distance between each of the nodes, which we will record. We've got previous node. That's just to keep a track of what node you are coming from, okay? And then we've got visited. Visited just means, okay, that we have exhausted all the nodes that each of these nodes is connected to. This will make sense as we work through this. So we've got 4 columns. These are the main 3, node, distance, and previous node. If you didn't include the visited column, you're not going to lose marks. You can just tick off as you go along, but I will remind you of that later. Okay, let's make a start with the first example. So A, if we're going from A, as in our starting point, and the destination is E. I'm just going to put an asterisk there. You don't have to. In the exam, they will tell you what your start node is and what your end node or destination node is. It doesn't always have to be A to E. It could be C to E. It could be C to B, whatever it is, okay? They will tell you that in the exam. So let's make a start. Now, before we've even moved, A to A, as in before moving, is a distance of 0, and there is no previous node. Okay, this is before moving. Now, we've got B and C that are connected to A. So we need to check the, or record the distance there. A to B is a distance of 40. Plus 0 is still 40. Okay, A to B is 40. The previous node, the node that you have just come from, is A. Okay, A to C is a distance of 50, plus the 0, which remains at 50. And again, the previous node that you have just come from is A. Now, we can tick off A as visited, because there are no other nodes connected to it. So we can now look at any one of these. We'll just take B, just because it happens to be of a lower value. But we will need to exhaust all of these or visit every single node to establish and confirm that we have found the shortest path. So B is connected to A, B is connected to D, and B is connected to E. We don't go backwards towards a visited node. So we're now going to focus on B to D, which is a distance of 30. Now we also need to include the value of B, because we can't forget that. So 30 plus 40 is 70. And the node that we have just come from is B, or the previous node. So we've got that. We're now going to go from B to E, because that's connected to B. So that is a distance of 30 plus B, which is 40. And again, that's 70. Previous node again is B. Right. There are no other nodes that are connected to B, so therefore we can tick that off as visited. We can now look at C, because we do have to check every single node. We cannot just read this visually and work it out. We have to show our full working out. So we're going to look at C. C is connected to A, but that's visited. So we're not going to go backwards. C is also connected to D. We have a calculation, but C to D could be of a shorter distance. So we need to check that. So C to D is 45 plus C, which is 50. And that gives us 95. And the previous node that we've just come from is C. Now, just looking at these two, if we're looking for the shortest path, that is not going to give us the shortest path. So I'm going to put a line through that. That's giving us 95, and we already have a path that's giving us 70. Therefore, we discard that. We put a line through it really clearly so that the examiner can see that we have worked it out and we've established that we're not going to use that path. Right, so C now can be ticked off as visited. The next unvisited node is D, and it's connected to B, but that's visited. We don't go backwards. D is also connected to E with a distance of 25. So I'm going to write that down. 25 plus the value of D, which is 70. And that gives us 95. And the previous node that we've just come from is D. And again, if we look at this, we can see that we've got a distance of 70 and we've got a distance of 95. We obviously want to go with the shortest path, so we'll put a line through that. And there is no other node that D is connected to that is not visited. B is visited, C is visited, and we've just worked out E, so we can tick that off as visited. E now is connected to B, but that's visited, connected to D, and that's visited, so therefore we can tick that one off as well. So we now have found, by visiting all of the nodes, our shortest path. And the way this is going to be represented in the exam is that we will record the path. Now the destination was E, so I'm going to write E down. We got to E from B, and we're backtracking. B, the previous node was A. So our path that we've taken is A, B, E, with a distance or cost of 70. Right, that is your working out. You'll get 1 mark for the path, you'll get 1 mark for the actual cost or distance, whatever that is. We don't need to worry about the values. If it was cities, it could be a distance. If it was flight costs, we don't need to worry about that. But the value is 70, and that is the path. You'll get marks for this. So this is normally going to equate to about 5 or 6 marks. We're going to have a look at one more example. Okay, so again, we've got a graph. It is weighted, undirected, and I've got the table ready for us. Now, notice, okay, that it's not A to E or anything. They can give you any letters. So I'm just going to record these into the table. And like I said, you may be given a table, which is fantastic, but you might not be. So L, M, N, O, P, Q. Okay, so I've written that out. It just makes sense to put it out alphabetically. And we're now going to start. So L, before we've even moved, L, as it is a distance of 0, and there is no other previous node. L is connected to M and N. L to M is a distance of 50. There's nothing else to add. Previous node that we've just come from is L. L to N is a distance of 30. Nothing else to add. We've just come from L, so I've recorded that. And we can tick off L as visited. There is no other node that L is connected to. Right, we now need to visit all of these, so we can just go in any order. Let's just start with N because it just happens to be a shorter or a smaller value. N is connected to L, but that's visited, so we're not going to go backwards. N is also connected to Q with a value of 60. So we've got 60, but we also need to add the value of N. Plus 30 equals 90. And the previous node that we've just come from is N. There's no other node, so we can tick that off as visited. Now let's look at M. That is the next unvisited node. So we've got M being connected to L, but that's visited, so we don't go there. M is connected to O with a value of 40. Plus the value of M, which is 50. And that gives us 90. Don't forget to record the previous node. So that's M. And there are no other nodes connected to M, so we can tick that off as visited. Now let's look at O. That's connected to M, but it's visited, so we don't go backwards. O is also connected to P, so we can record that with a value of 70. Plus the value of O, which is 90. So that gives us a cost of 160. Previous node that we've come from is O. There is no other node that O is connected to, so therefore we can tick off O as visited. P now is a node that we haven't ticked off as visited, so we'll look at that. It's connected to O, but it's visited, so we don't go there. P is connected to Q with a distance of 20, so we'll record that plus P, which is 160. That gives you a distance of, or cost of 180 with the node that we've just come from, which is P. Now, just looking at that, you can see that we've got a distance of 90 using a different path and 180. Now, that's obvious. We're looking for the shortest path. So therefore, that one we can put a line through. And we now can tick off P because there's no other node that it is connected to. And finally, we've got to Q. There is check that there's no other node that is unvisited, and there isn't. So we can tick Q off as well. And now that we've visited all of the nodes, we've now got our path, which is, and we're going to go backwards. So starting from Q, we came from N, L, and then that was obviously the beginning. So L to N to Q was the shortest path with a distance or cost of 90. Okay, I hope that those two examples have made sense. Do make sure that you practice the questions using the link provided.